Well, this time we're going to start with our two triangles. And we'll call this A, B, and C. And we'll call this one X, Y, and Z. And we're going to make the bold assumption that angle A is the same as angle X, and angle C is the same as angle Z, and we'll make the assumption that Z to Y is the same as it is from C to B. And the question is, would the triangles be congruent, or must they be, if I have a situation here which is angle, angle, and side equal to angle, angle, and side? Angle, angle, and side is what we have here. And what we know is that if all three sides of one triangle are congruent to all three sides of another, then they're congruent. And we know if we have a side, an angle, and a side, where the angle is included between the two sides, then the triangles are congruent. And we also know that if we have an angle, a side, and an angle, where if I had this angle, this side, and that angle, then these would also be congruent. The question is this one also going to work? And I'm not going to try to do it by construction. Let's just see if we can find something else working for us here. We know the three angles of a triangle add up to 180 degrees, so I can say that the measure of angle X plus the measure of angle Y plus the measure of angle Z is equal to 180 degrees. We know that. And likewise, A plus B plus C is also 180 degrees. The measure of angle A plus the measure of angle B plus the measure of angle C is also 180. And since those are equal both to 180 degrees, I must say that they must be equal to each other by substitution. I can take out the 180, put this one in its place, and I can say that the measure of angle X, Y, and Z add up to the same thing as A, B, and C, so they must be equal to each other. Let's do it in alphabetical order. The measure of angle A plus the measure of angle B plus the measure of angle C must equal the measure of angle X. I'm going to turn this sideways so I can write on it better. The measure of angle X plus the measure of angle Y plus the measure of angle Z. I'm sure you have better handwriting than I do. There we go. All equal to each other. But remember our original assumption. A and X were equal to each other. So if I were to subtract the measure of angle A from this side and subtract the measure of angle X from this side, I'd be subtracting equals from equals, and the results must be equal. And if I want to do the same thing for C and Z, I could subtract the measure of angle C from this side and the measure of angle Z from this side. And by golly, what's left is the measure of angle B must be the same as the measure of angle Y. So that means that these angles here must be congruent to each other. By golly, that gives me an angle, a side, and an angle equal to an angle, a side, and an angle, and we know that that works. So if this one works, this one here must also work. And as a result of that, we can actually prove that if we have an angle, and a side congruent to an angle, and a side, the two triangles must be congruent to each other. Triangle A, B, C must be congruent to triangle X, Y, Z. And we've shown that the angle-side method is legitimate, but we ended up with an angle-side angle in order to get it. This would then be a theorem, and these up here, those three are postulates.